Welcome all to the final class of the NPTEL previous year assignment solving section. Today we are going to see week 12 assignment questions asked in the year 2021. Myself Suraj P from Chemical Engineering Department, IIT Kharagpur. So let us go to the questions. This is the first question. Generally a gas or vapor is considered to be dash when it is concentration is in between the lower explosive limit and higher explosive limit, and the flammability for the liquid is related to its dash. So can you fill this, like when the concentration of the vapor is below LEN and HEL, uh, whether it is safe or flammable or inflammable. uh, so are you able to see my screen? Hello. So here there are two terms. One is lower explosive limit and other is the higher explosive limit. uh, we know that when the gas concentration can be ranging from 0 volume percentage to 100 volume percentage in the atmosphere. So so there are some terms called lower explosive limit and higher explosive limit. This is the lower explosive limit, this is the higher explosive limit. So so if the vapor released to the atmosphere is in the range below LEL, then there is not enough vapor for combustion to take place. So that gas mixture is very lean for combustion. So the gas mixture is too lean for combustion, and when the gas mixture range is in between LEN and HEL, it can form a combustible mixture. And when it is above HEL, it can surely uh, catch fire and can cause combustion. So it is very rich for combustion. So we can see some example of values for HEL and LEL. uh, so first we can see the value for acetylene. Acetylene's LEL is 2.5 and HEL is 100 volume percentage. And next we can see about hydrogen. Hydrogen's LEL is 4 and HEL is 75. So from this we can find that when hydrogen is present in the air in 4 volume percentage, it can catch fire. And that actually the principle of fire extinguishing is to decrease the concentration of combustible material below LEL, so that fire can be eliminated. So it is helpful for uh, this value range we need to know before extinguishing the fire, so that we can decrease the concentration of the combustible material in the environment, thereby decreasing its concentration below LEL. Then fire can be decreased, rate of fire can be decreased. So any mixture below LEL is considered to be safe. Here we can see the generally gas and vapor is considered to be dash when its concentration is in between lower and upper explosive limit. So here they have asked this range between LEL and HEL. Actually it is inflammable in between LEL and HEL. And it can catch fire, but when the concentration is below LEL it is safe to handle. So, and next term is the flammability for a liquid is related to the flammability of liquid is related to its flash point, and the flash point is the temperature at which the liquid gives enough vapor for so that it can, if any ignition source is present, it can catch fire. So flash point. And the based on the range of flash point, the liquids can be classified as class A, class B liquid and class C liquid. So let's see what will be the range of flash point for class A. So for class A liquids, the flash point is less than 23 degrees Celsius. Next we can see what will be that for class B. For class B, the flash point will be between 23 degrees Celsius and 65 degrees Celsius. And the final one is class C type of liquid. Its flash point will be between 65 and 93. So here the answer will be B, because when the concentration is between LEL and HEL, it is inflammable and catch fire, and the flammability of a liquid is related to the flash point of the liquid. So flash point is related to flammability. So let's see next one. Heart alarm is associated with dash and soft alarm depends on dash. Options are dedicated sensors, normal operating sensors. Option B, normal operating sensors and dedicating sensors. Option C, normal operating sensors, digital control. Option D, dedicated sensors and digital control. So please try to answer this by yourself. Like, what is the specialty of a hard alarm? Actually, hard alarm is used for application where a critical operation condition are taking place, which are directly dependent on the safety concern of the process plant. So actually in that case we need to use dedicated sensors in case of hard alarm. The set and we need to note that the set value for operation of set value is critical for the operation and safety in case of hard alarm. So let's see the example for an hard alarm. Let if some hydrogen leakage, if the hydrogen leakage happened in a hydro treatment plant, a powerful hard alarm will be released in the process plant. So it's an example of application of hard alarm. Hydrogen leakage in a process hydro treatment plant. Also some other examples are also there, like when the reactor temperature difference between the inlet and outlet become very large. For example, for a packed reactor in a hydro treatment plant, like if this is the inlet temperature T1 and this is the outlet temperature T2, when the change in temperature between outlet and inlet, that is delta T, which is equal to T2 minus T1, if it exceeds certain value which causes runaway reaction, like if it cannot exceed some cases it cannot exceed 20 degrees Celsius, even though this reaction will be exothermic, it cannot exceed 20 degrees Celsius. If it exceeds 20 degrees Celsius, then chance of runaway reaction is there. So in order to prevent this rise in temperature across the reactor, there is a alarm which is a type of hard alarm, and it uses dedicated sensors. And some in other cases hard alarm can also be found in the level when the level of the liquid in a absorption column exceeds certain level, half of the height of the absorption column, then hard alarm will be here in the process plant. So the level of liquid in absorption column, it's an example of hard alarm. Then we can see soft alarm. Soft alarm is used for normal operating condition which is not that much significant. Like soft alarm is that which there is no dedicated sensor rather it depends on the sensor used for normal operation. Here there is, in case of soft alarm, in case of hard alarm we have a dedicated sensor. But in case of soft alarm, actually it is a not that much important, so that not that much important type of alarm, so it is used for normal operations. So normal operating sensors can meet the need for soft alarm. So let's see the answer for this. The hard alarm is associated with dedicated sensor, and the soft alarm depends on normal operating sensor. So the option will be option A. Answer will be A. Next one, consider the following two statements. When the discharge from a high pressure drum is transferred to a low pressure underground drum, it is called as closed blowdown tank. Statement 2, when discharge is directly to the atmosphere, it is called venting. Choose the correct option from the following. Statement 1 is true, but statement 2 is false. 2 is true and statement 1 is false. Both the statements are true, both the statements are false. So we need to know what will be a closed blowdown tank. Like a closed blowdown tank is a tank that is present in the underground. It's a vessel. It's also known as CBD, closed blowdown vessel. So CBD vessel is usually placed underground. In the process plant, many sometimes some uh, due to process parameter fluctuation, unwanted products will be formed, which will be drained to vessels called knockout drum. Uh, that will be finally drained to slope. So before reaching the slope, it will be drained to. It will be going to close blowdown drum. So the feed from knockout pot will be from the process plant, and from the knockout drum the feed will be going to a CBD vessel. And it should be noted that the pressure in the knockout pot should always be greater than the CBD, that in the CBD vessel. And from CBD vessel the product will be either going to slope or to flare. It will be the vapor product will be going to flare and the liquid products will be going to slope. So here the statement 1 we can see, when discharge from a high pressure drum is transferred to low pressure underground drum, it is called as a closed blowdown drum. So here the statement 1 is true. From the process plant, the actually the in the process plant the reactors and other things will be having high pressure, which will be going to a knockout port. From knockout port, it will be going to CVD vessel. Statement 2, when the discharge is directly to the atmosphere, it is called venting. Statement 2 is true. When we discharge the hydrocarbons to the atmosphere, it's called as venting. But uh, we should note that we should never vent hydrocarbons directly to the atmosphere. Actually, it will be having safety issues. But we can vent uh, water vapor or steam uh, from the vessel to atmosphere. Also, we can vent plant air, instrument air, and nitrogen for purging. These things we can vent. Nitrogen for purging. Steam we can uh, do venting. Then plant air, which is also again used for purging application. So these things we can directly vent to atmosphere, but we should never vent hydrocarbon to the atmosphere. Hydrocarbon should be sent to sent safely to flare header. So the both statements are true. Here the statement 2, the term for discharge of directly to the atmosphere is called as venting. Statement 2 is true and statement 1 is also true. So the correct answer will be option B. Next one, in India, two grades of fuel oil, winter and summer, are differentiated based on the two grades of fuel oil. Here the answer is directly given based on the kinematic viscosity and the pour point at 50 degrees Celsius. Answer will be B. We know that the kinematic viscosity is the ratio of, it is represented by nu, which is the ratio of dynamic viscosity to density, and its unit will be meter square per second. And the pour point is the minimum temperature at which the liquid can be pumped so that it will not be frost at that temperature. So in India, the two grades of fuel oil are differentiated based on the kinematic viscosity at 50 and pour point at 50. Option B. Then next one, in flammable environment, electric fittings are pressurized with air. This is done to, option A, to reduce the power load, option B, to reduce electrical resistance, option C, to prevent entry of any inflammable gas mixture from the environment, option D, to improve the efficiency of instruments. uh, like we should note that a similar thing is done for storage tanks. in storage tanks always a positive pressure relative to the atmosphere is given. Positive pressure relative to the atmosphere is given in order to prevent the entry of air from outside to inside. So the pressure in the storage tank will always be greater than that in the always be greater than uh, that of the atmosphere in order to prevent the entry of the air into the storage tank. If there is some entry of air to the storage tank, then there is chance for uh, formation of flammable mixture and causing fire. So similarly we can see in flammable environment, electrical fittings are pressurized with air. This is done to prevent the entry of flammable gas mixture from the environment to the instrument. So the correct option will be option C. Like instruments like junction box are pressurized with air. So let us see the example for electrical fittings like junction box are pressurized with air. In flammable environment to prevent the ingress of flammable mixture that can lead to explosive hazard from electrical spark. So in junction box and other thing, chance for electrical spark is there. So the ingress of uh, flammable mixture to the junction box is prevented by pressurizing with plant air. So next question: among multiple optimal design solution with the same objective function value, the most attractive option is one where the objective function value is option A, least sensitive to variation of independent input variables parameters within their expected range. Option B, highly sensitive to the variation of independent input parameters within their expected range. Option C, 0. Option D, none of the above. Uh, so we know that during optimization, uh, we need to either minimize or maximize the objective function depending on the input parameters. So the objective function is to be minimized or maximized. In case if we have multiple, after solving the objective function, if you have like the main purpose for uh, main purpose of objective function is to minimize or maximize. So during optimization, the objective function is minimized or maximized. So if we got multiple optimal solution after solving the objective function, that that give that will give the same value of objective function corresponding to the different combinations of input variables. Then a solution with the objective function being less sensitive to input variable variation, which signifies that the objective function will remain at its desired optimum value even if there are some deviation in the input variables. It means that specific design remains optimum even if the input variables have some deviation from the standard estimated values, and is obviously more attractive option to adopt. So we need to have least sensitive to the variation of independent input variables within the expected range. Which is the most attractive option. So there should be least sensitive in variation of independent input parameters within the expected range. The correct option will be option A. So the main objective for the objective function is to minimize or maximize depending on the independent input variable, and we should never get a multiple optimal design solution. If we get multiple design solution, multiple optimal design solution, then we will get the same value for each design solution, same value after substituting in the objective function. And the solution with the objective function should be least sensitive to input variables or changes, which signifies that the objective function will be remaining at its desired optimum value even if there is some change in the deviation in input variables. So least sensitive to variation is required. The correct option will be option A. Next question: consider the following two statements. Mathematical model is a set of equations or inequations that represent the relationship between input and output variables of a process. Statement 2: the process simulator user configures a process plant and set the input variables for the simulation. Running of simulation generates the computed values of process output similar to that observable in a real plant. Choose the correct option from the following. Option A: statement 1 is true, statement 2 is false. Option B: 2 is true, 1 is false. Option C: both 1 and 2 are true. Option D: 1 and 2 are false. Let's see statement 1. In statement 1 it is written mathematical model is a set of equations or inequation that represent the relation between input and output variables of a process. Actually the statement 1 is true, and the next statement is also true, that the process simulator, what is the definition for process simulator? It configures a process plant and set the input variables for the simulation. So here both statement 1 and 2 are true. The answer will be option C. Next one, consider the following two statements. Statement 1, finalized design should be optimal and stable. Statement 2, stability relates to effect of input variations on design output. Choose the correct option of the following. From the following, option A, both statements 1 and 2 are true. Option B, both statement 1 and 2 are false. Option C, statement 1 is true and 2 is false. Option D, 1 is true and 2 is false. So let's see what will be the answer for this. Like a finalized design should be op optimal and stable. This one is true. Statement 1 is true, and also the stability relates. What is meant by stability is that relates to the effect of input variations on design output, and the effect should be low. How the input the effect of input variation on the design output, and the effect should be low for stable. Effect of input variations on the design output should be low. So here both statements are true, and the answer will be option A. Let's see, consider the following things. One, process information and drawing to define or describe the unit. The engineering documents and drawing combine. One, process information and drawings to define or describe the unit. Two, detailed specifications of equipment involved. Three, instrument index and data sheets. Four, cost estimation details. So the engineering documents and drawings combine, except cost, it will combine all the things, like to convey the process information and drawing to to describe the process unit. Like a engineering drawing are compiled to they are compiled to convey process information and drawings to define or describe the unit. It will give the detail of equipment specifications, and it will provide instrument index. As written here, it will provide the instrument index. It will provide the data sheets and the P&ID, process and instrumentation diagrams, but it will not give the cost estimation details. So it will give 1, 2 and 3 will be the answer. Option B is the answer. So let's see question number 9. Consider the following two statements about HACCP. HACCP is a structured procedure to identify and evaluate hazardous situation. 2. HACCP analysis identifies the causes and likely consequences for deviations from any specified intention. Choose the correct option from the following. Only one is true, only two is true, both 1 and 2 are true, neither 1 nor 2 is true. So let's see the statement for HASOP. HASOP is a structured procedure to identify and evaluate the situations that represent the potential risks to personnel, equipment, and environment. Like the procedure involves a systematic estimation of process or operation that may be part of an existing plant or process scheme in the design stage. It identifies the possible significant deviation from each specified intention, feasible causes, and likely consequences. So basically, it will identify the causes and consequence of an event. So HASOP is a structured procedure to identify and evaluate a hazardous situation. Like it can be done for a existing plant, can be done on part of an existing plant, uh, or it can also be done on the process scheme which is under design stage. So this will be done by uh, th- there will be a panel for discussing experienced panel for discussing the uh, causes and consequences in a certain scheme in an existing plant or in a design for a new plant. So they will be discussing what are the possible uh, causes and what will be its consequence of an event. So here both statements are true. So option C is the correct answer. Let's see the next question. Estimate the power in watt required to compress a gas whose molecular weight is 28 and the gas is to be compressed from 5 bar to 10 bar and the gas mass flow rate is 10 gram per second and the temperature is 27 degrees Celsius. The polytropic coefficient is 2 and the compressibility factor is 1. Here we need to know the equation for work done for a compressible process, for a polytropic compressible process. So the work done for a polytropic process is given by gamma into Z RT1 by M into gamma minus 1 P2 by P1 raised to gamma minus 1 by gamma minus 1 into M dot G. Here the gamma is the polytropic coefficient and compressibility factors is the Z. R is universal gas constant. T1 is the initial temperature. So we can write all these what all values are given. Molecular weight of the gas is given, which is 28 gram per mole. Initial pressure is given P1, which is 5 bar. Final pressure which we need to compress is given as 10 bar. we know the ratio of final pressure to initial pressure is known as compressibility compression ratio P2 by P1, usually given by represented by R. Then the mass flow rate of the gas is given m dot g, which is equal to 10 gram per second. Then we have already told polytropic coefficient gamma written given as 2 and compressibility factor set as 1. So we can directly substitute these values. Gamma is 2, Z is 1, and the universal gas constant is 8.314. Initial temperature should be in Kelvin. So here T1 is given as 27 degrees Celsius, which will be equal to 300 Kelvin. And the molecular weight is 28. P2 by P1 raised to gamma minus 1 by gamma. Gamma is 2 into mass flow rate of the gas, which is 28. So on substituting all these values and solving, we will be getting the work done for polytropic process as 737.93 watt. So the correct answer will be option C. So if you have any doubt regarding these discussed topics, you can ask me. Like you can either mail to me or to professor. Actually, on Monday there will be one live section from 3 to 4. So kindly attend that live section on Monday. If you have any queries, you can also post in the discussion forum.